Hi, this is Mr. Williamson, and today we're going to talk about carbon and a couple other subjects. Let's get started. Carbon is an organic molecule, or it is part of all organic molecules. All organic molecules contain at least one carbon atom, usually combined with hydrogen. That's why I like carbon dioxide, which is CO2, doesn't have any hydrogen in. On the other hand, something like methane, which is CH4, that's considered an organic molecule. This one has the hydrogen in it, whereas carbon dioxide does not. So an organic molecule is any carbon-based molecule with carbon in it that's combined with hydrogen or some other atom, and usually hydrogen, but could be some other atom in some way. Carbon is able to form 4 bonds with other atoms. Its atomic number is 6. And so when we look at a carbon atom, it has the nucleus, all right, which I'm not going to put all the protons and neutrons in, but then the innermost ring, it has 2 electrons, like we talked about. And in the second ring, or the outermost ring, it has 4, a total of 6. That means that there are 2, 3, 4 places there in which it can bond with other things. That actually works really well. Like you said, it's a really light molecule, really light atom, and it has 4 bonding sites. And that allows us to create all kinds of different shaped molecules. Think of it like your skeleton. Your skeleton does much more than just hold your shape, but your skeleton is what we hang all of your body off of. It has where we hold the muscles. It holds up your organs. It protects your brain, things like that. Well, that's kind of what carbon does. Carbon carbon atoms are what we can shape different molecules on, and that shape is what we give the structure to the molecules that we're talking about. So with carbon atoms, we can form like chains. We can take a carbon with 4 bonds, it has to have 4 bonding sites, and we combine it with other carbons to give us a long chain. And you got to think, every time you see a carbon atom, you need to have 4 bonding sites. So every one of these would have 4 bonding sites. What do we bond with them? Well, we could bond a lot of hydrogens. That's really bad writing up there. Sorry. We could bond 4 hydrogens, or not 4 hydrogens, but hydrogens with them. And then maybe over here we could put an O and an H. Okay? And no, you do not need to know that, but just understand that when you see carbon, whenever you see the carbon, you should see 4 bonding sites. All right? And as a result, we can make these chains. Or we can form rings. We can take that same carbon atom with 4 bonding sites, and we can combine it with other carbons, but we can make a ring instead. Now, each one of these would have 4 sites also, probably again attached to hydrogen maybe, or an OH. Again, you do not need to know this. I'm just showing you how it would work. But we can make rings. So we can make a carbon-based ring out of carbon. Okay, so we can make long chains, or we can make rings, or we can make branch chains. Same thing, except instead of all hydrogen, maybe this one's connected to another carbon, and they make rings. Every one of those carbons would have another, at least 2 more, 1 or 2 more atoms attached to it. So again, like this one right here would only have 1, but this one would have 2 here, 1, 2, and this carbon here would have actually 3. But every one of the carbons would have 4 bonds attached to it because of that carbon bond. The 4 outermost electrons allow 4 more bonding sites. This is going to be the basis of all the molecules that we talk about in the future of this class, is this carbon, the structure of carbon. All right? So keep that in mind when I talk about rings or branch chains or chains or something like that. It's because of the bonding sites in carbon. Changing subject slightly, we're going to talk about two terms that I'm going to use a lot of, monomers and polymers. All right. And I realize a mono versus poly sounds like it's like a disease against a high school. It's not. But that is actually could help you where we get the term polymer. All right. Poly high school actually means many subjects. As much as I am not a real big fan of poly, it is a really old school. It was founded in 1887, and the first graduating class only had 7 people in it, 4 girls, 3 boys. In 1911, they had to actually separate into 2 schools. They had a boys' school and a girls' school. And back in 1916, they actually formed right next to Poly High School. They formed a community college, which we now call RCC. They had a post-high school education, so you graduated and then you could continue going into high school, and that's what formed RCC. In 1924, the 2 boys, the girls' school and the boys' school, formed back together to form one. And it stayed that way until 1956, when they actually had to go double sessions. They had so many students, meaning that you would have half of the school would go from let's say 7 to 1 in the 7 in the morning to 1 in the afternoon. The second half of the school may go to 2 to 6 or something like that. There's just too many students, and that's when they opened up Ramona High School. In 1960. Rubidoux High School was supposed to have been completed. It was not completed, so they actually shared the campus at Poly. So Poly students went to school during the day, and I guess Rubidoux students went to school in the afternoon until they got the school completed. And then in 1965, they finally moved to where it is now. That's the 65 is when they opened up Poly as we know it today. There's been a couple doing some research on this. Couple interesting graduates from Poly. In 1914, Walter Gordon graduated from high school. Who was Walter Gordon? He was the very first All-American athlete at Berkeley University. He was the governor for the U.S. Virgin Islands, and he was a federal district judge. I should have looked up this gentleman's name, but it was they had one Nobel Prize winner in economics, and a Nobel Prize is big deal. So Poly has had quite a storied history. Still don't like them, but the term Poly is exactly what the school's named after. It's named after many subjects. Okay. Well, in this case, a monomer, the prefix mono, means one. Monomer is a single unit of a type of a molecule. All right. It could be a ring. It could be a chain. All right. So. But I'm going to use the word monomer a lot. And I'm also going to use, when you put a bunch of monomers together, we're going to use a polymer. That's a bunch of more, or more than one monomer put together. All right. For example, okay, the way you might want to think about this is that if you take a crow, that's the monomer. A monomer would be a crow. If you put a bunch of crows together, you get the polymer, which is a murder of crows. A large group of crows is called a murder. One crow, a bunch of crows is called a murder. Don't ask me why. All right. If you take a cow, that would be the monomer. If you have a cow, the monomer, you put a bunch of cows together, you get the polymer. We call that a herd. So you have the cow, and then you have a herd of cows. Monomer is the cow. The polymer would be called a herd. All right. If you take a sardine, it's a fish. You take a bunch of fish, it's called a school. All right, so the monomer is the fish, the polymer is the school of fish. You take a rhinoceros, you get one, that's the monomer. If you take the polymer, it's called a crash of rhinoceros, which is very appropriate because they can be mean. So the monomer, one, the polymer is called crash, more than one. Well, in biology, we're going to use the monomer for carbohydrates. I'm going to call it a saccharide. So you might have heard that, maybe like a monosaccharide or polysaccharide. And when we talk about these, I will obviously go into more depth. The monomer of a lipid is called a fatty acid. The monomer of a protein is called an amino acid. You've heard of those, I'm willing to bet. Amino acids are just the monomers, the parts, the one unit of a protein. A protein is a polymer. And then the monomer of a nucleic acid is called a nucleotide. So, if you have any questions, please feel free to ask in the answers. If we're watching this on Edpuzzle, if not, ask in class. I hope you understand. I hope you took good notes. If you didn't, go back. I'd be glad to help you out. That's it.